Hello, everyone. Um, Thanks for being here today. Thanks for Plasticity Forum for inviting me. This is a great honor, and as Ashwin said earlier, we are here to contribute, but as well as here to learn. Um, and been learning sitting back there. Some really great presentations so far. Um, Today, I do want to talk about a problem that is on our minds and a problem that's worth solving. Every day we see pictures like this, and the problem of plastics recycling can seem very overwhelming. But there is a light at the end of the tunnel. I want to talk about plastics recycling from a very specific use case today, and a use case that we at Magnomer have been focusing on for the past year and a half. The problem of PET bottle recycling in the US. About 3 million tons of PET bottles hit US shelves each year. 3 million tons of PET is available for recycling each year, and yet only about a third is collected. 2 million tons of PET never even reaches recycling facilities. This is a problem of capture, this is a problem of government infrastructure, of consumer education, and of people either not having the right economic incentive or not having the right tools to do the correct thing. And this is a problem that gets a lot of attention, and probably rightly so. There are companies, including Coca-Cola here, who spoke earlier today, where they're trying to increase capture rates, both in the US and across the globe. But there is a deeper, a bigger structural problem that arguably is more worrisome. Because of the 900,000 tons that do reach recycling facilities, about 40% of that is lost to contamination through the recycling process. And of the 500,000 tons that is converted to clean PET flake, PET type 1 plastic, all of it is downcycled to polyester fiber. In the US, only about 17,000 tons is considered to be bottle grade PET plastic. And I know we all love Doug's jacket a lot, but the goal is bottle to bottle recyclability. Bottle to bottle recyclability is less than 1%. Now, we can argue that maybe we shouldn't be looking at the 3,000 or the 3 million tons. We should only be looking at a smaller denominator number, the amount that reaches recycling facilities. But even then, the bottle to bottle recycling rate is less than 2%. This huge yield loss that happens through the recycle process is not just an environmental problem, it is also comes at a huge economic cost. Here is the price trend monthly price trend going back to 2005 of recycle grade, bottle grade plastic, which is in dark gray, and in orange is virgin PET. This is, we're drawing from a report that's published by the Closed Loop Partners in November of last year. As you can see, both prices kind of follow each other. Maybe one is a little more expensive every once in a while, but there isn't a huge difference in prices. But what is different between these two commodities is the cost structure. They're both chemically similar, the same. They can both be used to make bottles, but they come from very different sources. Virgin PET, the biggest cost determinant is the cost of the monomers, PTA, and it goes as the price of oil goes. The price of oil goes higher, virgin PET becomes more expensive. Recycled PET, on the other hand, is a different story. The same report also talks about the cost structure of recycled bottle grade PET. And the biggest price determinant, what I've marked here in red, is the price of the PET bale. The report actually uses a very interesting term, price of the bale adjusted for yield. Because if you really look at the price of PET bale per unit, the biggest cost line item in the 31 cents per pound is actually contamination. About 40% of the PET bale is considered to be contamination. 40% of the cost of the PET bale is lost because of contamination. Contamination is in 4 different categories. We often think of contamination as things that should not be in there. This is moisture, non-PET items, fines, things like metallic objects or whatever that is not in there. But the biggest line item in contamination is caps and labels. Here is the same statistic shown in a different angle. So this is the composition of PET bales in the US. Again, around 38-40% is contamination. Of the contamination, the biggest line item, about half the contamination, 16% of the bale is caps and labels. Now, you can't really have a bottle without a cap or a label. These are elements of the bottle design which are integral, critical to the functionality of the bottle itself, and yet it is the cap and the label which is the biggest contaminant in our recycling processes. How can this be? A cap and a label is typically made of a different type of plastic resin, as you might be very familiar with. It is a recycler's job to segregate these different items from each other during the recycle process. And this is a problem that is not being addressed by the design of the bottle. In fact, the APR, which is the Association of Plastic Recyclers, studied this contamination problem with caps and labels in more detail. Now, for those of you who were not familiar with the American market or with APR, APR is increasingly, it started off as an organization in the late 70s or 80s as the voice of the recyclers in the US, but it is increasingly becoming this uh, trade organization which consumer brands and packaging manufacturers are looking to for packaging design guidelines. And in this particular newfound role, that APR has been studying the problem of PET recycling and found that contamination in PET is not only caps and labels, is actually caused by a very specific kind of a label, the shrink sleeve label. Shrink sleeve labels account for about 4 out of the 5 cents of reduction in yield loss cost in recycled PET. Around 80% of the yield loss cost by contamination is because of one very specific type of label, the shrink sleeve label. Now, labels are come in different types. Shrink sleeve label as the ones you see on a maybe a V8 or a Gatorade or a similar high-end energy drink bottle, which occupies the entire bottle. And we don't design these labels for recyclability, and that is the problem. We design our bottle packaging for functionality, for ergonomics, for aesthetics. Shrink sleeve labels came about because they were aesthetically pleasing. They help sell more product on shelves. It grabs consumers' attentions. But when shrink sleeves were introduced, no one was thinking of what happens to the end of the life of the bottle after a consumer is done with this particular packaging. And this is a problem that's worth solving. And this is a problem that we at Magnomer are looking at from a very different lens, wherein we are putting recyclability on the table along with functionality, ergonomics, and aesthetics, and saying that what can we do with the current packaging? What can we do with the current bottle so that we also have recyclability as an add-on feature? As it was said earlier, I lead Magnomer. We are a startup that's based out of Boston. And we are looking at packaging, specifically bottle packaging and very specifically shrink sleeve labels as a way to design our packaging better, design our packaging for recyclability. At Magnomer, we have devised a magnetic coating, a magnetic marker, if you will, which can go on a variety of packaging items. These coatings do not require the consumer to change their use habits. They will simply still throw items in the recycle bin as they are supposed to. Once they reach recycling facilities, our magnetic coatings enable and give recyclers a tool to pick up these items simply using magnetic sortation. Magnetic sortation is a widely used tool and makes packaging or makes recyclability easy, enables us to get to zero waste, enables us to go to a more circular use of our current plastic packaging. Let me show you how this really works with our shrink sleeve coatings. The blue coating that you see on the bottle is a magnetic coating. This is a coating that's designed to sync with current manufacturability of label printing, and it is a coating that is magnetic in nature, which allows a recycler to simply pull it away using a standard magnetic separator. A very high level view of what happens in a reclaiming facility and how our coating really works. Bottles are typically shred during the recycle process. Oftentimes there is decontamination which involves bottle wash, which I have not shown in this flowchart for the purpose of keeping it simple. But you essentially have bottle shred that is flowing through the process. You have separation using an aqueous float sink tank, where lighter resins that are lighter than water float and everything else sinks. PET, which has a density heavier than water, will sink along with most shrink sleeve labels. It is in that final line and the final conveyor belt that you see there is where you have a mixture of PET with all different types of labels, specifically PETG included in it. Now, these labels, even though the densities are heavier than water and they're in this mixture, they're chemically very different. When going through the extrusion and blow molding steps, it will screw with your processing. And that is what contributes to the lower quality grade, which is existing not just in the US but globally. Sortation at that point is critical, and currently sortation of shrink sleeve labels such as PETG at that very step is less than 5%. There are a variety of methods that's involved, which includes drying of the flake, trying to suck up the lighter flake, but it's not efficient. And it's not efficient because the recyclers, they don't really have any technological tools at their disposal to remove the PET flakes, or the PETG flake rather. Our magnetic coatings means that a simple magnetic separator, a magnetic pulley, or an overband separator worth anywhere between $5 to $10,000 will be enable a recycler to pull away the shrink sleeve flake, leaving behind clear PET flake, leaving behind higher quality flake, which is closer to bottle grade plastic now. We have a quick demo to show how this really works. As I said, our coatings can be printed using existing high-speed printing methods. Bottle manufacturing itself doesn't see any changes. It is in this flake form where separation happens. And you see the blue coating in this particular mixture, which is now going to be separated away using a simple $3,500 magnetic pulley. The blue flake goes in a separate bin, leaving behind higher quality, lower contamination, clear PET flake. This approach came about, and this idea at Magnomer came about because we are looking at recyclability as an equal to other functionality that needs to go along with bottle packaging. Our ability to sort, a design to sort, is the design to recycle. And this ability to remove the flake away from PET in the recycling process imparts recyclability to the entire packaging and to the entire stream. But our value proposition is not just imparting recyclability. Our value proposition is the fact that we are able to add recyclability in conjunction with current manufacturing processes. And if I may add, we often get questions about, oh, wouldn't a recycler or reclaimer need to add a magnetic separator? And the answer is maybe, because oftentimes they do have magnetic separators already in their plants or facilities. While we were initially brainstorming and when Magnum was still in concept phase, we actually interviewed a bunch of recyclers and we asked them this exact question, that what if you had to install another magnetic separator at your end to reduce contamination? The answer that we often got, and I would like to cite one particular case where the recycler asked me, so this is like a $5,000 equipment, right? I'm like, yeah. So he said that if there is a possibility, not a certainty, if there's a possibility of us reducing contamination due to shrink labels by adding a $5,000 equipment, I'll take 8. So this is a no-brainer for recyclers. Magnetic separation is a technology that's been around for a while. And it also complements the manufacturing ability. We are not talking about completely changing supply chains for large companies. Our label magnetic coating complements current label printing. We work with current label converters and have showcased with pilots that there is no effect to bottling speeds or supplies. And it also doesn't really change anything majorly in terms of cost, which is a question also that comes up very often. That what is the cost of this coating we're going to add? Why would a manufacturer want to pay for this? The answer is manufacturers already pay for inks. Imagine a label having 3 or 4 different colors. Adding another coating is equivalent to adding another color to your label design. And there is a huge marketing ROI that comes out of it, not to mention that this is also a way to reduce cost and increase the amount of recycled content in your packaging. Another question that consumers and customers specifically ask us is, oh, can you make your coating in different colors? We show this blue coating to customers, and that question comes up often. And the answer is again, yes, because this recyclability is not a feature that it compromises anything else. Our coatings can be made in different colors. It can be made as a clear coat, so that brand owners, brand designers are not really changing their overall brand designs. We are not changing their brand artwork. And this is happening in conjunction with their current manufacturing and their design practices. And of course, food safety regulations also comes up often, which is also something that we comply by. So what I want to conclude with this particular talk is, if there's one take home point, is recyclability doesn't need to be something that is added and breaks away everything else. Recyclability can be a feature that can be an add-on that can complement current supply chains, and still we can get to a zero waste or a circular use for plastics. And of course, this is not the only thing that we are working on. I think I spoke to most of these benefits to better design already, but reduce contamination, reduce prices. By reducing the amount of contamination, the APR states that you can reduce prices of post-consumer recycled bottle-grade PET by about 4 cents per pound. Increased supply is also another benefit that is very obvious. And something that has come up in conversations with multiple stakeholders is the fact that once you provide recyclers the economic incentive to actually make higher grade quality PET, you are bound to have increased capture rates also, because recycling is no longer a commodity that is considered to be a waste. It is a commodity that we can make money from. As I alluded to a little while ago, shrink sleeve is not the only place where this can be applied. We have started prototyping a solution for bottle caps, which is also a big line item in terms of contamination. But what I want to leave you with the fact that improving economics of recycling has been long talked about as one of the goals to move to a circular economy. In fact, it is one of the largest line items that the Ellen MacArthur Foundation stated in its 3 broad strategies to move to circular plastic use. Under the bucket of increasing economic viability of recycling, it also talked about the use of material markers as means to improve sorting ability, and which is what we do, and which is what Magnomer's mission is. But it speaks to this larger mission that as we improve our recycling yields, as we reduce contamination in PET bottle streams or in other areas, we will increase the cost that is gained by recyclers. Currently, recyclers lose money during recycling. They make more money by hauling and landfilling stuff rather than recycling items. And as we increase the quality of our recycled streams by technologies and innovations such as we propose, we can get from the negative 170 to the positive. And that is a move to a circular economy. And what we call at Magnomer is a move to a more attractive recycling. Thank you very much.